Welcome back, 7th graders. All right, we're going to continue on in chapter 16, looking at different types of mollusks. Now, if you remember the chart I referred you to the other day, we said there are 3 major classes of mollusks, and today we're going to look at the class Bivalvia, the types of invertebrates that have 2-part hinged shells, and they're either marine, which means saltwater, or they can be freshwater. And some examples would be clams, oysters, and mussels. And in particular today, we're going to take a look at clams. These are mollusks that have a shell. So with that, let me share my screen with you. Okay, you should be seeing what I see. I'm going to full screen. There we go. All right, let's take a look at these particular bivalves. Bivalves are marine mollusks in the class Bivalvia. This class consists of over 9,000 species that can be found from the tropics to the Arctic, in shallow waters and deep waters. This includes organisms like clams, mussels, oysters, and scallops. The largest living bivalve is the giant clam, reaching over 3 feet or 1 meter wide. The majority of bivalve species are marine, which means saltwater, but some do inhabit freshwater. Most bivalves are sedentary filter feeders with a 2-part hinged shell that covers their soft bodies. 2 adductor muscles are used to close their shell, and they breathe through their gills and gather food also through their gills. To do this, bivalves draw in water and filter out the tiny suspended food particles like algae and detritus as the water passes through their gills. Alternatively, some species will ingest mud from the seafloor and extract or take out the edible material from that. Many species have a retractable foot that allows them to move and burrow into the sediment. Species like razor clams will bury themselves in the sediment and extend their siphon up to the surface to suck in water. Some species can swim through the water by snapping their shells open and closed. Bivalves, like mussels, have byssal threads that permanently anchor the adult to hard surfaces. Bivalves, like oysters, permanently cement themselves to structures. Bivalves grow with their shells. Their mantle secretes calcium carbonate that leaves a pattern of growth lines on their exterior. Their shell is reduced or absent in some bivalves, like shipworms. Bivalves can be hermaphroditic or have separate sexes. Fertilization is usually external, in which eggs and sperm are released into the water. Bivalves are important in keeping water clean. For example, the average adult oyster can filter 25 gallons of water each day. Contaminants like metals and naturally occurring algal toxins will concentrate in their bodies as they filter their food. This is called bioaccumulation. This doesn't hurt the bivalve, but eating a bivalve that has filtered too many toxic materials can be harmful. Bivalves are valued as a food source throughout the world. Global production for human consumption is estimated at over 15 million metric tons per year. Most are harvested by aquaculture. In the United States alone, we gather tons of these things. Annually, over 150 million pounds of bivalves. All right. Now, there's another fascinating look I want to show you, which has to do with what is actually inside of the clam. So we've taken a closer look at the outside. Now let's take a closer look at a dissection looking at the inside of the clam. What you're looking at is a clam's foot. And that's right, clams have a foot. In some species, it can extend several inches. But as it turns out, a foot is just one of the many bizarre features you'll find inside a clam. Like oysters and mussels, like we've said, they're bivalves. They're encased in a shell, and it's made of two valves. And here we're going to see that it has hinging parts, and they can come in all different shapes and sizes. These are small clams used for cooking. But then there's giant clams, which can grow more than a meter long and weigh as much as 250 kilograms. That's 551 pounds. But no matter their size, there's some bizarre stuff going on the inside. So we're going to get a closer look. So here we see two guys clam farming. This is a biologist named Soren Dahl, and they're on Long Island going clamming. So here they are. They're not having much luck. Oh, but then they find one, but it's dead. So they find another one. They find what's called a honey hole, which is basically a code word for jackpot. And so here he's got a couple of them. So in the end, they're finding about a dozen or so of these, and they're going to take a closer look at what's on the inside. You can't exactly pry one open with your bare hands, and that's thanks to these two muscles. They run from the inside of one shell to the other. And when clams sense a threat or find themselves out of water, they contract, causing the clam to, clam up. So to get one open, you need to cut through those muscles. So now you have, here's a hard shell clam, and both of those two muscles together, they go from one end to the other and side to side. What about that strange foot? So that's the foot he's pointing at right there. But they can retract it inside. That's why it's inside the shell. They'll extend that outside of the clam, and they can push themselves along the bottom and use it to dig a hole to help bring themselves into like a burrow. And some clams are particularly dexterous with their foot. The razor clam, for example, can bury itself 70 centimeters underground. It uses rapid movements of its foot to fluidize the ground to make it like a fluid, essentially turning it into quicksand. But if you think clam feet are bizarre, check out this thing, the siphon. Siphons are essentially two connected straws that clams stick out of their shells. One pulls in the water, which contains food particles and oxygen, and the other expels waste. And none is more impressive than the one belonging to the geoduck clam. It's so big, the clam can't even close its shell. While siphons allow clams to eat and breathe, some clams have another tactic, more advanced tactic for getting nutrients. Instead of just sucking food out of the water, giant clams farm it themselves. Like coral, they have a symbiotic relationship with microalgae. The clams provide algae with a place to live and photosynthesize, and in exchange, algae give the clam byproducts of photosynthesis, such as sugars, which enable the giant clams to, grow giant. Now, on rare occasions, there's something else you might find inside a clam, a pearl. That's right, oysters aren't the only pearl producers out there. Clams, too, will form these shimmering clumps to trap irritants that enter their shells. In fact, a fisherman once found a 34-kilogram pearl inside a giant clam. So, yeah, clams aren't just fascinating. They might also be precious. But they actually play an important role in their environment. By sucking up particles to eat, they function like natural water filters, making marshes, lakes, and other habitats more livable. And on top of that, they're delicious to eat, not to mention fun to collect. All right, now I want to show you when we talk about a pearl. Let's take a closer look at how is it that pearls grow. So look at this diagram with me of the formation of a pearl. A pearl forms when some irritant enters the mollusk shell and lodges between the shell and the mantle, or the outer layer of the animal inside. Now, that irritant may be a boring parasite or a particle of sand or wood, a small fish, or the mollusk's own eggs. The mantle epithelium encloses the irritant in a sac and secretes a layer of nacre or pearl around the particle. A blister pearl forms if the pearl grows against the shell wall instead of being completely enclosed. The nacre consists primarily of calcium carbonate crystals, which are held together by an organic substance called conchiolin, plus a small quantity of water. The nacre that lines the shell is called mother of pearl. It is lustrous and iridescent and is often used in jewelry. Wild pearl oysters cluster together in oyster banks that are usually 18 to 30 feet deep and no more than 60 feet deep. The optimum water temperature for producing saltwater pearls is about 77 degrees Fahrenheit. Mussels, which produce the majority of freshwater pearls, live in streams and small rivers and require somewhat lower temperatures than oysters in order to produce good pearls. Cultured pearls, like natural pearls, develop inside mollusks and are composed of nacre. Cultured pearls, however, begin with an artificially inserted nucleus. This nucleus is usually a round mother-of-pearl bead or a piece of another mollusk's mantle. It takes about 3 years to produce a cultured pearl of good quality. A pearl mussel may yield as many as 50 usable cultured pearls in one crop. A saltwater oyster, however, usually yields at most 2 cultured pearls and dies when the pearls are removed. All right, let me stop presenting. Okay, guys, well, that's a close look at mollusk, in particular the clam, and also in particular the pearls that they produce. Don't forget to take a close look at your exit slip, fill that out for me, and Google Classroom for any and all assignments. If you have any questions, don't forget you can email me, and I will talk to all of you later.